Hi there. This is the video summary of the lesson on reflections that we covered on December 3rd and 4th in my geometry class. So reflections are a different way of transforming objects. You can move them around. And what we started with was kind of looking at like how reflections work by typing in different equations of lines. And I gave suggestions like, what if you typed in the equation for, I don't know, the x-axis, which is y equals 0. And we do that, and look what happens. We get this new triangle that's kind of flipped over that that line of, we call that the line of reflection. And we tried it with other things like x equals 0, and then now the mirrored triangle is on the other side of this darker line here. And then we even tried some other things like, I don't know, a different vertical line like x equals -3 is kind of interesting. Because when you do that, the line goes through the purple triangle, so the orange triangle's sort of flipped over right on top of it. We even tried some diagonal lines like y equals x, and you can flip over those things. But the key to learning how to do reflections is you'll notice that it's all about distance. Like let's look at a different one that's maybe a little bit easier to see. X equals -2. I chose this one because you can kind of see point C, for instance, is right on the line, so it doesn't move away from the line. But this point B went from being 2 units to the left of the line, and now it's 2 units to the right of the line. So it's all about doing distances, getting the distances correct when you're doing reflections. And we're going to take some notes on that in just a moment. But so after we did that little exploration, what do you notice, what do you wonder? I had everybody sort of try to figure out, like, could you get this purple triangle to land on this orange triangle by typing some equation here? And I'll just do one of them for you. This one was the y-axis. And the equation for the y-axis is x equals 0. And see that how the reflected triangle is on top of the original triangle? So I encourage you, when you open up this, this file in GeoGebra that you'll find on Schoology, to try figuring out the lines that make these triangles match. And so then after we did that for a little while, we switched over to note-taking, and we took some notes on reflections. And a reflection is really quite simple. It just means to flip over a line. But what's missing from this diagram, and you should copy this into your notebook, but what's missing from this diagram is a label for this line. This line right here has a special name, and it's pretty simple. It's called the line of reflection. It's the line over which we're taking our original object and creating an image by flipping it over that line. And the transformed object is congruent to the original object, right? This and this are the same size and shape, but the new object is a mirror image. It has the orientation flipped over. And like I was just saying, the distance is the key. Point B, for instance, here, right, and point B prime are the same distance from the line of reflection. These distances are the same, this one and this one. And that's true of all 3 corners. And on all the points, really, the distances are the same. And that's how you do a reflection by hand. So like, again, point C is the same distance as point C prime, and so on. So we took notes on that, and then we did these 2 examples, which you should take a moment and copy them into your notebook. So you can pause here, but then what we did was we learned to reflect over some lines and by hand. And the first one I wanted to do is I wanted to reflect over the x-axis. And you don't really, if you copy this into your notebook, you don't really need to redraw the x-axis. It's already there. I'll put a red line there just in case. And what we did was we said, okay, let's reflect this over the x-axis. And again, it all has to do with distances. Like, think in your head, how far away from the x-axis is point A? Well, it looks like it's 2 units down, right? That's 2 units down. So the new point A would be 2 units up right here. See, that distance is the same. Instead of 2 units down, it's 2 units up. So we'll call that A prime. B is 2 units up, right? So the new B would just be down here at 2 units down. There's B prime. And point C is the really special one. That's sitting on that the line of reflection. It's already on the line of reflection. It is not any number of units away. It's 0 units away. So if that's the case, you can just leave it where it is, and that's the new C prime. And then you can connect the 3 dots, and then you've got your reflected triangle. And this was a good example because it's it's what happens when the line of reflection is going through your original object. The new object, this green triangle I drew, is sort of just a flipped version of it. I flipped it over on itself. And then we did this second example here where we reflected over the line y equals x, which, as you recall from algebra, is a line with a slope of 1 that goes through 0, 0, right? Every coordinate, or every point on the line, the x and the y coordinates are the same. So 1, 1, 2, 2, 3, 3, 4, 4, and so on. So the first thing to do is to graph the line. And then if we're going to reflect over this line, remember it's all about distances. And what I told the students in class is when I'm reflecting over these special lines, y equals x and y equals negative x, those have a slope of 1. So what you can do to count those distances, I call it counting corners. Because you want to measure that distance, the distance from each point to that line, along a perpendicular line. And without getting into the details, the way to do that is you can just go corner to corner. See this point B here? If I go corner to corner, it's 2 corners away from the line. So you know where B prime is? It's 2 corners in the other direction. It's right here, right? So it's not 2 units. It's like, what is that? It's 2 root 2, but that doesn't matter. I just count corners. Point A is, let's see here. If I go 1 corner, but then it's like another half of a corner. See how the distance is like 1.5 corners? Well, I would do the same thing, go in this direction, and that's how I find A prime. That's 1.5 corners. And then C is like 1, 2, 3 corners. And so to find the C prime, I would go 1, 2, 3 corners in this other direction. And so now what I did was I flipped that triangle over this line, and I created a reflected triangle here. I guess putting A prime in that spot made it kind of ugly, so let's write it out here. But again, it all comes down to counting distances. So then the last thing I asked students to do in class was to try to graph or to do some of these by hand. And so what you would do, like here's one example, I would start by graphing the line of reflection. It says reflect over the x-axis. And I know that it's already there, but let's just make a line. I use my line tool to make a line of reflection. And then if I want to reflect over the x-axis, again, it's just about counting distances. So I see that A is 2 units above the x-axis. So the new point, which it calls F, I guess, is 2 units below. C is 2 units above, so the distance below would be 2 again. And B is what, 3 units above, so I would go 3 units below to make my new point. And then I've got a reflected version of that triangle. So I would encourage you to, after you complete the notes, to try these other problems in the GeoGebra application, and then after you do that, I'll have posted the answer key so you can check your work there. So good luck with that, and I'll see you next time.